We have engine ignition, RD-180 at full thrust. As GEM 63 chamber pressures look nominal. Vehicle's begun the pitch yaw roll maneuver and tower clear. RD-180 engine parameters look good. View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance. We have passed through Mach 1. Vehicle is now passing through max Q, maximum dynamic pressure. Now, 55 seconds into flight, Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour. RD-180 is now throttling back up. Now, at 75 seconds into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour. Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second. SRBs have burned out as expected, and we see a good SRB jettison. Vehicle is now executing closed loop steering. Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly. Vehicle performance continues to look good at this time. Tank pressures are stable and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels. We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison. And we've seen a successful payload fairing jettison. RD-180 is throttled back up now. And the vehicle has reached a 4.6 G acceleration limit and will maintain this level through BECO. We've seen that the Centaur has begun its boost phase chill down sequence. And BECO, booster engine cutoff. Standing by for stage separation and a successful stage separation event. And we've seen pre-start on the RL-10. And mass 1, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes. We're seeing the expected activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning. Upper stage systems look good at this time. Hydrazine line temperatures are approaching the bottle temperature as expected. The engine propellant utilization system has gone to closed loop control, and the engine response remains nominal. I just received word from the trajectory and performance group that booster performance was as expected for the booster phase of flight. The engine propellant utilization system is performing as expected, controlling the mass error to near zero. And we have indication of successful spacecraft separation of the GOES-T spacecraft.